like I said, I like today, it's simple, it's a good review, coming back, of course, after Thanksgiving break. We're gonna talk about ratios and proportions. And you're like, what does this have to do with geometry? Because most of the problems today seem like algebra, and they are. But, of course, we're gonna do some geometry with it. We're gonna see some triangles come back at us in the upcoming sections where you're going to set the sides proportional, AKA you're gonna make some fractions and do some cross products. We will get into all of that in a minute. Now, there's nothing for you to write. This is all on your note sheet. We just need to talk about how you can represent a ratio. And there's 3 ways you can do it. I don't care which way you do it. First off, ratio, you're really comparing 2 quantities on your fraction. Now, you know I love fractions, right? So I generally do it this style. I generally write it in fraction form. You can write it with the word 2 in it, but you know I don't like to write, it's math, right? Or the other way I generally do it will be this one. The dots means the word 2. So just be aware of that. Generally, I will do it fraction style. Now, ratio is simplified form. So there's my next question for you. Do you know how to reduce fractions on your graphing calculators?
No.
So let me show you just in case you need that. So again, let's say you want to reduce, I don't know, 10 over 22. You could do it in your head, I'm well aware. But let's say you're worried, you want to make sure it's right. So on your graphing calculator, there's a couple ways you can do it. I can type in 10 divided by 22, and it's too many 2's there, sorry. 22. And it's going to give you, of course, the decimal answer. If you hit on the left side, math, enter, enter, that will kick it out as a fraction for you in simplest form. Or a lot of them, not all my yellow ones, not all of them, but a lot of them you can hit alpha and then the key right to the right of it, and it pulls up that horizontal fraction bar, and I can just do my 10, 22, and it goes straight to it. You can also, depending on your model, hit alpha and then the top y equals, and hit enter, and that would pull up the fraction bar and do the same thing. So I don't care how you do it, as long as you can reduce the fractions. If you need help in your calculator, let me know. I'm happy to look at that with you. All right, now last thing, of course, we're not going to see this a lot, but it might pop up this chapter, to simplify ratio with unlike units. So that means maybe you have inches as one of them, feet in the other. Well, you can't compare them if you're in different units of measurement, so you'd have to do some conversion. Like you need to know how many inches are in a foot.
12.
12. So you might have to multiply by 12 to put everything in inches style. You have to be in the same units. Most everything is, but once in a while, this chapter, that will not be the case. All right, super simple. Here we go, my friends. So the girls' basketball program has 6 seniors, 8 juniors, 12 sophomores, 14 freshmen. State the ratio for each of the following. So you're comparing seniors to freshmen. So easy enough, I'm just going to take a look. I see there are, of course, how many seniors? 6. How many freshmen?
14.
And then, of course, good mathematicians that we are, we reduce that. Probably can do that one in your head.
I'd say 3 over 7.
Perfect. So you know I love fractions in here. I generally lean to writing everything as a fraction, but remember, you could write it like that also if you prefer that style. I don't care. Okay, sophomores to total. Well, of course, we can all read up here. We see that there are 12 sophomores. You're going to have to do a little bit of math here. I need to know how many total kids there are. So how many when
40.
you add your senior, sophomore,
There's
freshman?
40.
40. So we're going to do 12 compared to 40. Either you do it in your head or your calculator.
3
Let's
over
reduce
10.
it. 3 over 10. This is what you're doing today, my friends.
This is so easy.
I know. Okay, juniors to sophomores. How many juniors?
A lot.
8. How many sophomores? 12. Let's reduce. Final answer.
2 over 3.
Perfect. All right, and let's do the last one of this.
7 over 20.
Freshmen to total players. How many total freshmen first? 14. Let's start with that. Total players, we said. 40. And we reduced it down, of course. Got it. And remember, I don't care. I lean towards fraction style. You know I love a fraction, but you can write them like this. You can write it with the word 2. I find that kind of irritating, but however you want to do it. I tend to go to the fractions. Any questions on those first 4? I know that's ridiculously easy. Read close, right? Okay. All right, let's throw in some geometry. The ratio of 2, I love it. Good review, thinking about our final. Complementary angles is 3 to 7. Now, you have to know, and I know you know, that complements add up to 90. So that's where I'm getting the equal 90 from. Of course, you might see today the word supplements. Humor me, I know you know it, but supplements add up to what?
A lot.
180. Okay, now we have two of these angles, so I'm going to put two blanks in here for each angle. Now, to get our expressions for the angles, you have this ratio of 3 to 7. So that means you're going to take the first angle, whatever it is, I'm going to use x for the variable and times it by 3. And then to get the second, I'm going to multiply my variable by 7. So that's the tricky part, that's the setup. Now it's easy. Combine your like terms, 3x, 7x, let's make it 10x. X is what? 9. Now, final answer, remember, wants the measure of the angle. So you got to do a little back substitution, so to speak. Put 9 in here for x. What's 3 times 9? So I'm going to put 27 degrees. What's your second angle? What's 7 times 9? 63. And obviously, 27, 63, they combine to 90 degrees. We've seen these types of problems before. It's been a while. Might just need a little review. All right, ratio of the measured angles in a triangle, 4 to 7 to 9. Find the measures of the angles. So the first question is, where are we heading this up to? So angles in a triangle, you know that. All three angles in a triangle add up to what? 180. Got it. So that's where the 180 comes from. Now same thing, we've got our three angles. So I'm going to put 3 blanks in. And they give you the ratio at the end down there at the first line. 4 to 7 to 9. So I'm going to have 4x, 7x, 9x. So there's the setup. Any questions on that?
No.
All right, let's solve it. What's 4x plus 7x plus 9x? How many x's? 20x. X equals 9. Okay, final answer. I need all three angles, so put your 9 in for it. What's 4 times 9? 36, my first angle. What's 7 times 9? 63. And last but not least, 9 times 9.
81.
Got it.
So can we do the homework now?
Come on, now, come on. I know, it is easy. I got some spicier stuff on the back. All right, last one on the front. Ratio of the measures of the sides of the triangle, 2 to 8 to 9. Keyword, perimeter. Now, how do you find perimeter of any figure? Add up all the sides. So we are adding the 3 sides. That's why I'm adding, because we're doing perimeter. And you just got to read it. What's the perimeter? 76. Okay, let's fill in the ratio part, 2 to 8 to 9. So 2x, 8x, 9x. Let's combine our like terms over there. You're going to have a total of 19 x's. And I think Michael just said the answer for us, x is 4. That was a good guess. Okay, back substitute your 4 in, but you can mental math it. What's 2 times 4?
8.
Now, degrees or inches? Inches, we're finding sides. Good catch there. What's 8 times 4? 32. And my last side, 9 times 4? 36. Got it. And like I said, you probably on the homework will see one where it has the word supplementary in there. I know you know it adds to 180, not a big deal, but just reminding you of that. All right, last thing, it's like Algebra 1, my friends. We're going to review how to solve proportions. Now today we're just doing basic algebra style. We will have some triangles and compare some sides and put a geometry slant on this in the upcoming sections. Today we're just practicing our cross multiplication. So of course, proportion, you have your 2 fractions, your 2 ratios set equal. Remember, you just multiply the diagonals and set them equal to each other. And it does not matter what diagonal you start with, you pick. All right, let's do it. We've done these, it's just been a while. All right, because I'm standing here and I don't know, I feel like doing 10 times 5 first because it seems easy and do it in my head, right? And then I'm going to do my other diagonal, 8 times x. Now, piece of cake, solve that, don't really need a lot of work. Is that going to come out to a nice answer though? No. 6.25, good. Yeah, you are going to get some decimals today, so don't let that scare you. I know, it's craziness today. Okay, same thing, I'm going to pick a diagonal. I'm going to do 4 and 15 first because those seem easy. What's 4 times 15? 60. Now, the other diagonal is simple, but we got to be smart here. You have to multiply 3 to that entire expression, x plus 4. So let's review our vocab. I'm really using what property? Distributive. Distributive. That was one of our properties back in the day. 3 times 4, of course, 12. All right, I'm going to give you a second. I know you're great at solving equations. Subtract your 12, finish it from there. This one comes out nice.
16.
Got it. Any questions on how to get the 16? Too easy. This is ridiculous. Okay.
Can you get negatives?
Yes. Okay, let's take a look at this one. So same thing, I'm gonna do this diagonal first. Now, a lot of you might skip this step now that we've reviewed that and go straight to what that is distributed out, which is totally fine. But you know, the love of math, I'm gonna write everything. And then we have to do our 8 and our x plus 7. So like I said, some of you might skip that red and purple step and go right to this one, because I know you're good at distributing. 2 times x, 2 times 19. 8 times x. What's 8 times 7? 56, good on the times tables. Okay, let's get the x's on the same side. I'm gonna subtract 2x from both. Ooh, fancy, a variable on both sides of the equation. Okay, 8 minus 2. I'm gonna give you a sec. I know you could finish solving this. You should get a nice number, Because what's 38 minus 56?
18.
Negative 18.
That's what I was thinking.
And that comes out nice. What's x?
Oh,
Negative 3. Now, remember, let's just, because I'm always thinking about the final coming at us, we've always kind of been a little panicky about negative answers in here because we're usually finding angles or sides on a figure. Are we finding angle or sides here? No, so negative's fine. Who cares, okay? Now, you might be like, we got this. Why are we doing one more? Of course, I got to kick it up. So I'm going to start easy. What's 6
Why
times
do we have
5?
x squared?
And here comes the fun part. We have to multiply these together. So we have to figure out how we're going to do x plus 1 times x plus 2.
Do we have to use FOIL?
So we're going to FOIL it out, distribute it all the way out. Let's see what happens here. I'm a little worried. All right, first, outer, inner, last, or just distribute everything together, x and x.
X squared.
So right now, I know there's going to be how many answers to this? 2. Okay, outer, x and 2.
2x.
So now I have to distribute the 1 through to everything. Or first, outer, inner, I'm on, and then the last. So of course we're going to combine these like terms in the middle. Let's make that 3x. Now, to get our 2 answers, we are going to have to use one of our favorite F words in math. Factor, there's so many good F words in math. We're going to factor. Before I factor it though, we have to set it equal to what? 0. So I would subtract 30 over. Mine too.
Well, yeah, you're right.
Okay, so 2 minus 30, got it.
Yeah, negative 20.
Let me scroll it up so I'm not clear at the bottom. Now, times tables, gotta know them. What 2 numbers multiply to negative 28 and add to 3?
Well, I'm gonna go 7 and 4.
7.
Minus.
I like 4,
Negative
let's
four.
put a negative on it so we make the 3.
Yeah, my
That's my apologies.
That's all right.
He's mental mathing.
Okay, final 2
I'm quite annoyed with
solutions.
that.
Got it.
So what she said.
7.
Now, we have obviously solved by factoring in here before. It's just been a hot minute, so I just wanted to review how to do that, okay? Not a lot of these on the homework, but you will encounter it. Questions on that?
Awesome sauce.
All right, final thing. Sorry, Logan, go ahead.
By the way, I was going to say fudge.
Okay, for your, okay.
Why are you
All right, final 2 problems. Here we go. Gotta do some word problems.
I guess I want to enlarge a picture.
Here we go. Michael wanted to enlarge a picture to a height of 12 inches. What would the new width of the picture be if it was originally, catch that part, the originally 5 inches tall, 7 wide? So I'm going to start with that. Now clearly we're on this kick of ratios and proportions, so I'm going to show you I can use that to a word problem. Now it doesn't matter if you do the height over the width or the width over the height. We just have to be consistent on it. So I'm going to do, because I don't know, I feel like it, I'm comparing the heights to the width. This is how I'm going to set up my fractions. I can't write and talk. Width. So when I set up this original fraction here, because I'm going to make a proportion, so am I going to make it 5 over 7 or 7 over 5? Okay. And again, you could have it flipped, but you just have to be consistent and have your other one flipped. Now, he wants to enlarge the picture for a height of 12. So are you putting the 12 on the new fraction on the top or the bottom? Top, because that's where we put height. And it wants you to figure out the width. So I'm going to put that as my variable. All right, easy peasy. Let's do our cross products. What's 12 times 7? 84. 5 times x. That's easy.
It's not going to be.
Now, is this gonna come out nice?
No.
No, use your calculator.
That's what I was thinking.
So you should get 16.8.
You just like wasn't sure, so you didn't say it out loud.
And let's label it.
Yeah, she got it.
Inches. Good. Okay, final problem. And again, this is super easy. Don't let the fact it's a word problem. So Samantha went to the store and bought 5 packs of gum. There are 36 pieces of gum in each pack. How many pieces of gum did she buy?
Can I not just do 36
I was gonna say, I don't even know if I'd write work on this quite frankly. I'd probably just do it in my calculator. So I'm with Maddie. I would do 36 times 5. 5 packs,
I'm gonna go
36.
180.
Why does she know that?
Well, she needs a lot of gum. She wants
Yeah,
to
but
have
how
much
much
back.
that
I don't
cost
know.
though? My breath used to be.
Oh boy, now we're down the rabbit hole. Okay, any questions on that guy? Do I need on your homework for you to write 5 times 36, or could you just slap down 180? Okay, all right, so nothing too crazy today. Obviously, you have your worksheet. I'm gonna grab it.